Okay, so in the last video, we worked out how much money would be in a savings account if we invested $5,000 at 9% per annum with interest paid monthly over a period of 3 years. So from this, the cumulative amount, which is given by A, capital A equals the principal by 1 plus the rate to the power of how many payments there are. We quickly substitute these numbers again. We've got $5,000 by 1 plus 0.09, so that's 9% as a decimal, over 12, because we are paid monthly, to the power of 12 times 3, which equals 36. So 36 payments, and that gives us a total of $6,543.23 at the end of that term. So this is how much we'd earn with compound interest. Compound interest being interest on top of interest, or interest on interest that is already paid. Let's call this problem 1, because we'll compare it now to problem 2, where we have the same $5,000 at 9% per annum over 3 years with only simple interest. So simple interest is interest that's only applied to the principal amount. We don't calculate interest on interest that's accumulating in the account. So the formula for the accrued amount is capital A equals the principal by 1 plus the interest rate by the time or the term of the deposit. And in our case, we have $5,000 outside of 1 plus 0.09 by 3, so 9% per year by 3 years. And if we put this in a calculator, we get the amount $6,350. This is what we should see in the bank account after 3 years. So this is with simple interest. So let's compare with compound interest. We got $6,543.23. With simple interest, we still did pretty well. We got $6,350. So compound interest only worked out to be $193.23 more over 3 years, which is a fairly decent amount of time. So you might be thinking, what is the hype with compound interest? I'm not getting that much more than simple interest. In fact, after 3 years, it works out to be only 3% more of the accumulated amount we would have got with simple interest. Okay, well that's fair enough, but the substantial difference comes in when we are prepared to be more patient and wait a few more years. So let's see what happens if these monies were allowed to accumulate in their respective accounts over, say, the next 10 to 15 years. So here on this chart, we have two curves. The orange curve is the accumulated amount with compound interest, with its formula A equals the principal outside of 1 plus the rate to the power of the number of payments. And the cyan curve is for simple interest, and its formula is the accumulated amount is equal to A equals the principal outside of 1 plus the rate by the term. And at the start here, at time equals 0, we started with $5,000. Here at 3 years, we can see the respective amounts we calculated before, and we can see the difference here is $193.23. But as you can see, as time goes on, the curves diverge and the difference gets larger and larger and larger. So at 10 years, the cumulative difference is $2,000 $756.78, and at 15 years the difference has widened to $7,440.22. So you can see that compound interest grows faster and faster and faster as time goes on, and this is because compound interest is a classic form of exponential growth because of this power that's in the formula here. So it grows quite slowly at the start, but as time goes on, the growth really takes off. Simple interest, on the other hand, is linear growth, because the growth rate, which is what the interest rate is, it doesn't change. And this is why partly your mortgages are so difficult to pay off, because your bank is compounding interest on your home loan, but you're only repaying that with a constant set payment. Okay, so I hope this video has helped with your understanding of the difference between compound and simple interest. Please like it and share it with your classmates. Subscribe to my channel. If you have any questions, ask me in the comment section below. Till next time, best of luck with your studies, and I'll see you on the next video.